I'd like to first start off with stating Archimedes' principle. A fluid exerts an upward buoyancy force on an object immersed in or floating on a fluid. The magnitude of the buoyancy force equals the weight of the fluid displaced by the object. So if we have an object that floats, we can see here that the floating block displaces fluid, which is equal to the buoyancy force, and the weight of the block is also equal to the buoyancy force. So we take the weight of the fluid displaced and set it equal to the weight of the block. Now the weight of the fluid displaced is equal to the density of the fluid times the volume of the fluid times gravity. And the weight of the block is equal to the mass of the block times gravity. So you can cancel out the gravities and get that the density of the fluid is equal to the mass of the block divided by the volume of the fluid. But what happens if an object sinks? Well, if an object sinks, then the volume of the fluid displaced is equal to the volume of the block, which means that the density of the fluid then becomes the density of the object. So we have the equation that the density of the object equals the mass of the block divided by the volume of the block. We will now test Archimedes' principle by lowering a known mass into a volume of water. We can see here that by lowering the mass into the water, we have a displacement of 16.5 milliliters. As previously stated, the density of the object is equal to the mass of the block and the volume of water that is displaced by the block. I weighed the block previous to submerging it into water and got a mass of 146.1 grams. And we saw from the video that the volume of water displaced was equal to 16.5 milliliters, which is equal to 16.5 cubic centimeters. So we then calculate the density of our object by taking the mass of the block, which is 146.1 grams, and dividing it by the volume that the block displaced, which is 16.5 cubic centimeters. We then get a density of the object to be 8.85 grams per cubic centimeters. The object that was displaced was made of copper, and the actual density of copper is 8.92 grams per cubic centimeters. Considering the sources of error that might be involved with kind of guesstimating where the exact milliliters displaced were, I feel like Archimedes' method is a fairly accurate method for calculating the density of object when it is submerged in water.